I'm Anil Kumar. I'll discuss solution of sum or difference of few infinite series in this particular video. Now my emphasis here is that you should really forget about tricks. There are no shortcuts in understanding mathematics. You have to learn the correct methods. So the idea is to learn correct methods to solve problems. That is kind of very important, right? So we have four examples here. Let us see how to solve such questions. All these are infinite series, so they're all tending, when we say these dots, that means the series goes on and on. So we need to find sum or difference for these numbers, which are radicals. So we have square root of 12 plus square root of 12 plus square root of 12 and so on. Then we have a series with difference, square root of 6 minus square root of 6 minus square root of 6 and so on. Now these are factorable, and then we have the similar series with prime numbers like 7 and 11. We'll try to understand how to solve such questions. What you need to know is very simple things. So let's understand what we need to know. So we need to know how to solve quadratic equation. That is a must. So for any competitive exam also, you should review how to solve quadratic function. So if I have a quadratic equation y equals to ax squared plus bx plus c, then what is x? Apply the quadratic formula, which is minus b plus minus square root of b square minus 4ac over 2a, right? So this is the way you have to solve quadratic equation. Now at times, if you have a quadratic equation which is factorable, you can just factor and get your solution, right? So let us see one by one how to solve these questions. You don't really have to apply tricks, because I've seen many students getting the answers by applying tricks. It works at times for multiple choice questions. For example, here they will say, well, 4 times 3 is 12, and since 4 is a bigger number, we are doing addition, so the answer is 4. Here they will say 3 times 2 is 6. When we do take away, the answer should be 2, and likewise. So you have some special formulas for prime numbers also. But we are not going to apply tricks here. We are going to understand the method. Okay. So here's the very first one. We are saying we need to find what is all this. Now we can write, let this all be equal to x, correct? It has to have a value. So if this is equal to x, then what is x square equals to? When we square, then this square root will vanish, and we get 12 plus square root of 12 plus square root of 12 plus so on. Well, this series is similar to x, exactly same rather, since there are infinite terms. So we could write this as 12 plus x. So what do we get? We actually get a quadratic equation. Do you see that? So we have equation which is x squared minus x plus 12 equal to 0. Now if you want, you can apply the quadratic formula, which is x is equals to minus of minus 1, which is 1, plus minus square root of b square, which is 1, minus 4ac, I'm sorry, this is minus 12 when you bring it this side. So 4 times 12 is 48. So we get plus 48 over 2, twice a, right? And you can solve, get your answer, which is 1. It is actually plus and minus. 1 plus and minus square root of 49 over 2. We know square root of 49 is 7, so it is 1 plus minus 7 over 2. So we get two solutions here. The first one could be 1 plus 7 divided by 2, that is 8 divided by 2, which is 4. The other one is 1 minus 7, which is minus 6 divided by 2 is minus 3. And we know this solution has to be greater than 0. Whenever you have radical sign, always it is greater than 0. Therefore, we know this is correct and this is not correct. So we get our solution. Perfect. Now some of you could also factor it directly. We are looking for two numbers whose product is minus 12, sum is minus 1. So we could write this as x. So the bigger number is negative, right? So we get x minus 4 times x plus 3 equals to 0. Now there are two solutions from these factors. One is x equals to 4, the other one is x equals to minus 3. And therefore, we know that the answer is x equals to 4. Since x has to be greater than 0, this is not valid. So we get our answer as x is equals to 4. So it is simple. Just substitute the whole thing as x, square both sides, and then solve it like a quadratic equation. So I hope you get the point, right? Now, for this question, you can pause the video, answer, and then look into my solution, right? So what do we get here? Let me say this is equal to x. When I square, then I get 6 minus square root of 6 minus square root of 6 minus square root of 6 and so on, which is equals to x square. And now bringing x square, we could write all this as x. So we could write this as 6 minus x is indeed equals to x square, or bringing them together, we get 0 equals to x square plus x minus 6. Now 6 could be factored 3 times 2. Bigger number has to be positive. So we get x plus 3 times x minus 2. So we factor it. Now this is factorable, so it is good to use factoring rather than the formula. So here we have two solutions. One is x equals to minus 3 and the other one is x equals to 2. For all radicals like this, we know that x has to be greater than 0, right? It has to be a positive value. It could be equal to 0 also, but it cannot be negative. And therefore, this is not valid. So the only valid solution is x equals to 2, correct? So that is how you can get the answer within no time. But at least you are doing the right method. And this method always helps. Now we are looking into a question where we cannot really factor. So we can write this as equal to x, apply the same method, square both sides. You get x square equals to 7 plus square root of 7 plus square root of 7 and so on. So which is x square plus 7 plus all this is also x, since it is an infinite series, right? So now bring them all together. We get x square minus x minus 7 equal to 0. Since we cannot factor it, let's apply the quadratic formula. So we get x equals to minus of b, which is 1, plus minus square root of b squared, that is minus 1 square, minus 4ac, 4 times 1 times minus 7, over twice a, which is 2, right? 2 times 1 you can write. So we get 1 plus minus square root of 1 plus 4 times 7 is 28, right? Divided by 2. Or we get 1 plus minus square root of 29 divided by 2, right? Since we know that x has to be greater than, or it could be 0, but it cannot be negative. Therefore, what is our answer? So we know the valid answer is x equals to 1 plus square root of 29 over 2, correct? So that is the answer for this particular question. Now here is the last question, which I think you can do yourself now. So the last question here is, this is again a prime number. 11 cannot be factored. Let it be equal to x. So what is x square equals to? X square is 11 minus square root of 11 minus square root of 11 minus and so on, right? Which could be written as x square equals to 11 minus x. Bringing them together, we get x square plus x minus 11 equals to 0. And now apply the quadratic formula. So x is equals to minus 1 plus minus square root of b square, which is 1, minus 4ac, which is plus 44 now, divided by 2 times a, which is 2. So that gives you minus 1 plus minus square root of 45 divided by 2. Since it cannot be negative, what is your answer? X is equals to minus 1 plus square root of 45 over 2, right? Of course, 45 can be written as 9 times 5. So I could also write this as minus 1 plus minus, rather plus 9 times 5, so 3 square root 5 over 2. Do you see that? So that becomes the solution of the given question. So I hope now you will avoid those tricks, apply correct method so that you could do similar examples without any problems, correct? So now you can find solution of x equals to square root of, let me add a number here, 13 plus square root of 13 plus square root of 13 plus so on till infinity. So that's practice question for you. Okay. Thanks a lot for watching. All the best, and if you like and subscribe my videos, that'll be great. Thank you and all the best.